So welcome back guys. Now we will going to discuss the problem of bounded waiting. We will discuss what bounded waiting is, why does it happen, and we will discuss what is the solution of this problem. You can read a textbook definition of this keyword bounded waiting on the internet, but you would rarely find any program which actually demonstrate the problem of bounded waiting and then suggest a solution for it. So this is what I will going to discuss in this section of this course. So to start with, let us start with our discussion on bounded waiting with some real world scenario. So let us suppose that you go to the Pani Puri wala and you take your bowl and wait for your turn. So those who do not understand who Pani Puri wala is, you can see the picture on the right hand side. So in the Asian countries, especially in the countries like India, we have a street food which is most famously called as Pani Puri. So people usually approach a Pani Puri wala, that is a guy who is selling Pani Puri, and the people just approach such a guy and surround this guy and wait for their own turn, and this Pani Puri wala serve the Pani Puri one by one. So each of the people who surrounds this Pani Pura stands with a bowl in their hand so that Pani Puri seller can put a Pani Puri in their bowl and they can eat. I'm explaining this because there could be some couple of students who may have not witnessed such a street food in their countries, so bear it. But anyways, going forward, you understand. So it so happens that the seller distribute Pani Puri to everybody else but you. Alright? So it makes you feel a little bit angry and humiliated. So we will say that there is a lack of bounded waiting. If seller wants, he may make you wait for forever until you yourself quit out of humiliation. So mapping this real world scenario to a world of thread synchronization, when multiple threads wait on the same condition variable, problem of bounded wait may arise. So let's say you have a call to pthread condition wait somewhere in your program. Alright, and you are passing the address of the condition variable along with the mutex to this API. Now let's suppose that the thread T1 comes and it hit this line. So what happens? The thread T1 gets blocked. Alright. Now the thread T2 comes. And likewise the thread T1, the thread T2 also get blocked. Similarly, thread T3 comes, hit this line and get blocked. And so on. Now at this point of time, there are three threads T1, T2 and T3 which are blocked on the same condition variable CV. Now let us suppose that within the application there is some other thread T4 which generates a signal. So let's call this signal as S. Your operating system may deliver this signal S to any one of these threads who are blocked on the condition variable. And this process is quite random. So let us say that your operating system delivers the signal S to the thread T1. So the thread T1 unblocks and resumes. The thread T1 resumes its execution. Alright. Now let us suppose that the thread T4 again generates the signal S. And now your operating system chooses the thread T2 to deliver the new signal S. So your thread T2 resumes its execution. Alright. Now let us suppose that there is some other thread T5 which comes and hit this pthread condition wait call and gets blocked. Alright. So now at this point of time, the thread T3 and T5 are in the blocked state. Now some other thread in the process, let's say the thread T4 only, generates another signal S. Now let us suppose that your operating system chooses the signal S and delivers to the thread T5. So the thread T5 resumes its execution. Now again, let us suppose that there is some thread T6 which comes and get blocked at this wait call. Alright. Now again your thread T4 generates a signal S, and let us suppose that your operating system chooses the signal S and delivers to the thread T6 so that your thread T6 resumes its execution. So you can see that theoretically I can say that the thread T3 is a bit unlucky thread such that your operating system never chooses the thread T3 to deliver the signal. If we assume that your operating system never chooses the thread T3 to deliver the signal, then it means that the thread T3 would continue to stay blocked on this condition wait call. So note that your operating system randomly delivers the generated signal S to one of the threads who are blocked on this condition wait call. So at some point of time, if you assume that there are 4 threads which are blocked on this condition wait call and some other thread in the system generates a signal S, then your operating system randomly delivers this signal S to one of the blocked threads, and whichever thread receives that signal, that particular thread resumes execution. So now the question is that because of this randomness, that is, your operating system chooses the lucky thread to deliver the signal, there is theoretically a possibility that some thread out of these blocked threads may stay blocked forever. Now note that I'm saying this theoretically. When theoretically one can argue that some thread blocked on a condition variable shall never get a chance to resume execution, then program lacks the property of bounded waiting. As simple as that. Though your operating system out of some randomness chooses one of the threads and deliver the signal to, so practically you may not see one of the threads waiting on the condition wait call for forever. Sooner or later, all the threads would going to be delivered the signal S, provided that enough number of signals have been generated. But one can always present the argument that one of the threads among these blocked threads would stay blocked for forever, and you cannot deny their argument because you yourself cannot produce the formal proof that all the threads would eventually going to be signaled. So when there is an indeterminism as to which block thread shall resume execution on receiving signal, then the problem or program lacks the property of bounded waiting. This is just another words of saying that the program lacks the property of bounded waiting. When the signal is generated, the operating system just choose one of the blocked threads randomly and deliver the signal to that thread. So there is indeterminism. As a developer, you cannot say that which of these threads, that is T1, T2, T3 and T4, would going to resume its execution when some other thread generates a signal. So when this kind of indeterminism is there, we say that the program lacks the property of bounded waiting. Now the third way of saying is that whenever there is a possibility that a thread may never get a chance to enter critical section, then the program lacks the property of bounded waiting. So bounded waiting is a favorable property, and a program is said to be a good program if it shows the property of bounded waiting. Note that as soon as a thread resumes their execution beyond this condition wait call, what follows the code after this is a critical section. Alright, so whenever one can argue that one of the threads may never get a chance to enter into its critical section, we say that the program lacks the property of bounded waiting. So now in 2 sentences, if I were to say that what is the root cause which causes your program to not to show the property of bounded waiting, you will say that waiting of the threads on the same condition variable is one reason, and the randomness shown by the operating system in choosing one of the threads waiting on a condition variable to resume their execution upon signaling is the second reason that causes the program to not to show the property of bounded waiting. So waiting on the same condition variable and the randomness. So these are the 2 things which prevent the program from showing the property of bounded waiting. In the subsequent lecture video, I will going to discuss the code snippet in which the property of bounded waiting is lacking, and I will show you that they lacks the property of bounded waiting because the condition 1 and condition 2 both are satisfied. And then I will show you that how both the conditions can be removed so that your program starts showing the property of bounded waiting. In other words, I will show you that how bounded waiting can be ensured in multi-threaded programs.